Hi, me and my groupmates are going to give a video walkthrough of the C++ code of SLR parser. So, my name is Sam Sarkar and my roll number is AP21110010286. So, let's start. So, first of all, we're including the header file of the C++ code. So, we're using the base std c++.h. What it does, it actually includes most of the necessary C++ header files at once. So, we don't need to actually individually add those header files. So next, we're using namespace std to actually import all the functions that come under the std namespace, so that we don't have to use the std colon colon. So next, we come to line 9. So in here, we're actually declaring all the C++ containers that we're going to need for the overall code to run. So the first container is the vector container, which consists of pair template and which consists of a nested template of character and string. So here we're making two vectors of it. This contains mainly the production rules, and then we're declaring two int variables that contains the index of the sets, and then another vector contains the non-terminal terminals, and then we're declaring a map consisting of char and int. This is mainly a map for mapping of the terminals and non-terminals. And then we are declaring a table, a 2D array, that's SLR table, and a vector as well, that's a transition table. Then we are declaring a queue as well for the functions to run thoroughly, and the first one follow, and the epsilon vector, as well as a visited array to keep track of the visited nodes during the execution. So the first function we come around is the is non-term. What it will do mainly, it will mainly check that if the particular character is the non-terminal or not. What it's essentially checking is by the if condition is that whether it contains between the capital A and the capital Z. If it will, then it will say yes, it is. Otherwise, no. So let's come to the next function, that is the makeSet function. And what it takes as is the pair, the template of character and string. And now we are declaring another queue consisting of character and string. Now, what we're essentially checking is if mean uh, if the pair B is within the set C or not. If it is not in that particular set, then we will push back to that set as well as push back to the queue as well. Now what we are doing is we are declaring a while condition that will run infinitely until unless the queue is empty. So what we are doing is we're popping the first element from the queue, and then we're checking that where the dot actually is. So you can see if we're able to find the dot, we're um, updating the pos variable with a particular index. And next what we're doing is in this what we're checking is, for example, if we find a non-terminal in the right side of the production rule, we're just adding it to the particular set as well as adding it to the queue. Now let's come to the next function, that is the check function. What it does essentially is it checks if the two sets are same or not. If it is, then it will it will return the particular index of the set, and if it's not, it will just say -1. And let's go to the next function, that is the go-to. So first of all, we are declaring two variables, that is the found one as well as the triple K one. So the found one actually stores the index of the particular position where we find able to find a dot, and the triple K will actually store like a boolean. So if it's found, it will say true, or it will say false. So in the for loop, we're just checking in the loop whether we're able to find a dot or whether there is a um not whether it's a trouble symbol after the dot. So if there is one, so we're updating the found variable as well as the triple K variable for it. So next we're checking if the triple K variable is true or not. So that means there is a dot as well as there's a terminal following the dot. So now what we're doing is we're adding all the production rules, I mean the terminals before the dot to the XX variable, as well as now we're adding the dot, and at the end, what we're adding is the remaining after the non-terminal, that is the production rule. Now what we're doing is we're making a set of it. Now, after coming out of this if condition, we're checking if the set size is 0 or not. If it's 0, we are just exiting the function instantly. Now what we're doing is we were checking if the sets are same or not. If it's not same, what we're doing is we are changing the main parsing table, as well as we are checking if in the transition table also, if it is there. If it's not there, we are adding it to the transition table as well. And in the queue also, we are pushing the same variable to it, but we're incrementing for the next iteration as well. So if it's the same, then what we're doing is we're just clearing the set Z because we don't need it anymore. Now, next what we're doing is we're checking again the transition table. If it's there, then it's fine. If it's not there, we're just pushing back to it. So, and in this function, the mark itself function, we're just checking if the second part is empty or not. If the second part is empty, so we'll just push it to the epsilon function. So and the following the first total function will be explained by Sanjana.
My name is Sanjana and my roll number is AP21110010313. Now we'll be looking at calculating the first and follow of every variable or non-terminal symbol. Here the first util function is a utility function which is used by find first function, and this the computed first of every non-terminal symbol is stored in the vector v. Next, these lines check whether this non-terminal symbol has already been computed. If the first of that non-terminal symbol is already computed, then it returns without any further processing. If it is not computed, then it marks the non-terminal symbol as visited. Next, here we have the for loop. This loop basically goes through all the productions in the given grammar and search for productions where the non-terminal symbol, that is, we here declare the non-terminal symbol as LHS. So it searches for the productions where the non-terminal symbol appears on the left-hand side. So the left-hand side is basically pi dot first. That means the left-hand side, and it also checks that the right-hand side is non-empty. So here, while j less than max is a loop which iterates through all the symbols in the right hand side of the current production rule. So it basically it iterates through all the symbols on the right hand side one by one. Uh, uh, then this if function is if a loop is basically, it checks that if the current symbol is a non-terminal or not. If that symbol is not a non-terminal, and if the symbol is not already in the set v, that is, if the first is not already calculated, then it adds it to the set uh, then it adds it to the set v, and then breaks the loop, say, as all the terminal symbols have been found. Next, if this is not the case, then if the symbol is a non-terminal, then it calls the first util function to compute the first of that non-terminal symbol, and adds the computed set again to the set v as we did above. And if find ep dot begin, ep dot end, pi dot second is equals to ep dot end, that is, it checks that if the epsilon is not in the first is not in the set of first of that particular non terminal symbol, then it breaks the loop since epsilon is not in the first, and it increments the j to move to the next symbol in the right hand side of the production. This basically, then what happens is, if j equals to max L, so this block is executed when the whole loop is completed. That is, if the entire right hand side symbols, all the symbols on the right hand side of the production are processed, only then this if block is executed. And if the loop reached till the end of the right hand side, that is, all the symbols on the right hand side are processed without encountering a terminal symbol, then it means that epsilon is the first set of that non-current. It means that epsilon is in the first of that non-terminal symbol, and so we add epsilon to that first set of that particular non-terminal symbol. Next is the void find first function. It initializes the visited array and then iterates through all the non-terminal symbols. Here, nt is basically the non-terminal symbols. We denote it as nt. So this function basically initializes the visited array. It keeps a track of what all non-terminals have been visited, and then goes through all the non-terminal symbols. So then this for loop is basically uh, saying that for each of the non-terminal symbol, it calls the first util function to compute the first of that non-terminal symbol and stores the result of first of that particular non-terminal symbol in the vector v. Then uh, here meme set is basically a predefined function in C++, where it has three attributes: pointer, value, and number. Here like pointer means a pointer to the memory block, value is the value which has to be set, and number is the number of bytes to be set for that particular value. So here in this line, visited is the pointer, value is 0, and number is 10 into size of int. Next, coming to the follow util function. So this function, just like first util, it is a utility function to keep a track of the first of all the non-terminal symbols. So here, if visited empty LHS equals to 1. So similarly, just like we did in first, so these lines check that if the follow of that particular non-terminal symbol has already been computed. If it is already computed, then it returns without any processing. If it is not computed, then it marks the non-terminal symbol as visited. Next, if LHS equals to P0 dot first, if we begin V end, dollar equal to V end, then we push back dollar. So this block basically tells that if the non-terminal symbol, that is LHS, is the start symbol of the grammar, that is if it is the first symbol in the first production, then it adds dollar to the follow set of that particular non-terminal symbol, because we know that for the starting non-terminal symbol, the follow of that non-terminal symbol we write dollar. So similarly here we write dollar if the non-terminal symbol is the start symbol of that particular grammar. Next, for int I equals to 0, I less than p size I plus plus. So this line basically is a loop that iterates through all the productions which are denoted by pre. So it iterates all the productions in the grammar. And if int max equals to pi second dot size, so it says that it calculates the length of the right hand side of the current production. So right hand side length is calculated and then it stores in this variable max L, the max length function variable, and then uh, it goes into the next for loop, which is which iterates through each symbol in the right hand side of that given current production rule. And if it checks that if the current symbol in the right hand side is equals to the non-terminal symbol for which we are computing the follow set. So if the current symbol is equal to the non-terminal symbol on the left hand side for which we are calculating the follow, then it increments the j to move to the next symbol on the. Then there is another loop which checks that it iterates through each symbol on the right hand side of the production, and if it checks that if the current symbol on the right hand side is equal to the non-terminal symbol on the left hand side for which we are computing the follow, then it increments the j to move to the next symbol on the right hand side. Next, while j less than max L, so it starts the loop that iterates through all the remaining symbols except that first symbol in the right hand side. And then if that current symbol is a terminal, that is if it is not a non-terminal symbol, then it checks that if the terminal symbol is not already in the follow, then it adds it to the set. If that terminal symbol is in the follow set already, it does not add it to the follow set. If that terminal symbol is not already in the follow set of that particular production, then it adds it to the follow. And then we break out of the loop as all the terminal symbols have been found after the given non-terminal symbol. And otherwise, if the terminal is a non-terminal symbol, if the symbol is a non-terminal symbol, then what we do is it gets the index of the non-terminal symbol, and then it iterates through all the first of that non-terminal symbol and checks that if the symbol from the first set is not already in the follow set. If it is not, then it adds it to the follow. If it is already in the follow set, it does not add it. And then uh, if find ep dot begin, ep dot end, pi second j equals to ep dot end. So this line basically checks that if the epsilon is not in the is not in the first of a non-terminal symbol, then it breaks out, since the first does not contain an epsilon, and increments the j to the to move to the next symbol. Here again, if the j is equal to max L, so if we have reached the end of that right hand side, that is, we have checked for each and every symbol on the right hand side, then it recursively calls the follow util function for the left hand side of the current production. So it basically recursively calls, that is, calls the same function repeatedly for the left hand side of the current production, that is pi dot first. So next we go to the find follow function. This function basically computes the follow of every non-terminal symbol. So void follow, this is the declaration of a function that does not take any argument. Next, for I equal to 0, I less than nt dot size I plus plus. As I already said, nt stands for non-terminal. So here it is a loop which goes through all the non-terminal symbols in the grammar, and meme set visited 0 size of int into 10, which is it is a set to all the elements. It sets the all elements into the visited array to 0, and it has three arguments, as I already said: pointer, value, and number. So here pointer is visited, number is 0, and value is 10 into size of integer. Next, we calculate character c equal to nt of I. So what it does is it basically retrieves the current non-terminal symbol from the vector nt and assigns it to variable c. And then follow util. So it calls the follow util function to compute the follow of that current non-terminal symbol c. Then the result is stored in the follow vector of that corresponding to the current non-terminal symbol. So here basically that's it. Thank you.
Hello, my name is Paras Agrawal and my registration number is AP21100100324. Now let's talk about find production function. The find production function searches for the given production x in the vector p, which is vector of productions. It returns the production number, which is 1 indexed if found, else otherwise it returns -1. Now, what are the input that it takes? It takes input x, which is the production to be found, a pair representing a non-terminal and a string. And what output does it produce? It produces a return function, and if not found, then -1. And if we see uh, through the code, there is a for loop running with some conditions, and hence it is returning the production, and if not found, then it is returning -1. So now coming on to the print stack. Here the print stack, this function prints the content of two stacks, which is S1 and the states in the formatted way. It pops elements from the stack and constructs a string h, as we can see, and constructs a string h from the character stack and an array a from the integer stack, as we can see here. Now, then it prints the elements in reverse order separated by spaces. Now, what are the input arguments and parameters here? The inputs are S1, which is a stack of characters, and states, which are which is a stack of integers. And then what output does it produce? The output, the contents of a stack to the console. Those are the output that is produced. If we go through the code, we can see here are some declarations. Then we are running a while loop and we're checking if the S1 stack, which is stack of characters, is empty or not. Hence, we are updating the values of h. We are creating a string h here, popping s, again s loop, checking the states if they're empty or not. And finally, we are running a for loop here and printing out the content of stacks to the console. Now we move forward. Now coming to parsing function, it checks whether the given string uh, it can be parsed given SLR parser using SLR table. Now, how does the initialization works? We take two input strings. We take input strings from the user. Then we initializes the stack S1 and the state initializes a pointer to 0, which is positioning to the input string here. Then pushes the initial state 0 onto the stack. Now, also there is parsing loop here. We are running one whole complete loop here. Parsing loop that continues until the end of the string is processed and prints the current state of the stack and remaining input string. We are performing here shift actions. If the entry in the parsing table for the current state, which is X, and current input symbol, which is Y, is positive, it means the shift action is performed. Then input symbol is pushed onto the character stack S1 and the state is pushed onto the state stack. Also, we are incrementing the pointer. Um, As we move next on the symbol table, we are performing reduce actions here. If the entry in the parsing table is negative, it indicates a reduce action, retrieves the production number, and adjusts it for one based indexing, as we already discussed. Pop symbols from both stacks on the length of right hand side of the production. As we know, we have to obviously pop them out of the stack. Also, we are performing error handling here. If neither shift nor reduce action is applicable, entry is 0 and error is printed and the program exists. And also the ultimate aim here is the acceptance. When the entire input string is processed and passed successfully, it prints accepted, as we can see here. Otherwise, it gives us error. In this condition itself, and we exit the loop. Now, here, um, when we talk about the input and output of this function parsing, we don't have such expressive input parameters here. And the output is again, we check whether the input string is accepted or not. Moving forward, now coming to printing transition table function. Uh, Once we note what's the output here, the function essentially prints the SLR parsing table in a tabular format. Each row corresponds to a state and each column corresponds to a terminal and or a non-terminal. The entries in the table indicate the action to be taken or the state in the transition to based on the current state and input symbol. Now let's go more deep into the function, how it actually works and what all the functionalities are actually happening here. We come to loop over states. The outer loop iterates, as you can see here. The outer loop iterates over each state, which is represented by I in this case in the SLR parsing table. Then print state index adds extra spaces for single digit state indices to maintain alignment, as we can see here. Separator prints a separate, obviously a straight line to print separate the index from the entries in the we can see here parsing table. Also, we are looping over terminals and non-terminals. The inner loop here, the inner loop iterates over each terminal and a non-terminal in the grammar. Then we are printing entries, which is the most important part of this function. And also we are printing a new line so that we come to our new state, as we talk that each row represents a new state. Thank you.
Hi, this is Tanishk Yadav, AP2 triple one double zero one zero two double six. Now coming to the main function, I'll go ahead with firstly describing that this particular section is responsible for including the necessary C++ header libraries. The bits stdc++.h actually includes all of the header files by default. So to be honest, we didn't need string, but this is just to emphasize that the string library will be used very frequently in our code. Now coming to the main function. Yeah. So coming to the main function, this is the part where we will be firstly printing out uh, we'll be just giving the prompts to the user. Firstly, this particular part will show the instructions. It will be printed as soon as the runtime starts. Now we'll be taking like some declarations are there, int n, which will be for the number of productions. We'll be asking the users, and character C, which will be taken in for entering the LHS of the production. That is from if it the statement is from S to AB. So C, the string character C will be on the LHS, and for RHS we'll be taking a string because it can be a complex part like this one. So it will be iterating through the loop, and every time when the LHS and RHS pair is taken, I will make a pair and we'll push back in the vector p which we declared in the very start. Now coming to this part, this particular section, or to be honest, this entire section. In this segment, the code identifies the terminals and non-terminals within the provided grammar. It uses vectors, anti and term, which were also defined in the very start, to store non-terminal and terminal symbols respectively. The function is non-term, which was explained earlier. Uh, Checks whether a character is non-terminal or not. The mapping M, which was done in the start, uh, I guess it was the first function itself, assigns unique indices to terminals, non-terminals, and the end marker, that is the dollar symbol. Now, after this, we'll print a new line character and we'll call the mark epsilon function. After this, we'll go ahead with printing the first of each like this line. We'll calculate the first of each non-terminal. This section basically calculates first from this function and then prints the first sets of each non-terminal in the grammar. The find first function uses a DFS approach to traverse the production and determine the first set for each non-terminal. The results are printed for each non-terminal using the loop. Now, after this, again, we'll print end line character and we'll go ahead with calling the find follow function. This part will print, and after that, this part will print the follow sets for each non-terminal in the grammar. Similar to the first sets, find follow function also utilizes the DFS approach to traverse the production and determine follow set for each non-terminal. The results are then printed for each non-terminal. Uh, Coming to make sets, this part will create sets and the go to uh, sets, the go to operations. It initializes the process with augmented grammar's initial set, which contains the items in the form x to dot s, where s is the start symbol. The sets are created iteratively using a queue-based approach, and the go-to operation is performed for both non-terminal and terminals. Now, coming to this loop, we'll be finding the reduction entries. And the code identifies the entries for LR0 sets. It finds items in the set where the dot is at the end, indicating that there's a reduction. For each such item, it identifies the production rule and assigns the corresponding reduction entry in the parsing table. Now, this part, the we'll go ahead with printing sets in the parsing tables. This part prints the LR0 sets and checks for multiple entries in SLR table. The print TT function is invoked if there are multiple entries. Otherwise, it proceeds to print the SLR table. Now, the, the entire table. This is the formatting structure for the table. Now, at the end, we will be calling the parsing function. This part is just for like if you want to check a string, that can this string be a part of this grammar, this function will be called, and you can put an input string, and it will determine that if the string can be passed by the given grammar. So thanks. Now we go ahead with executing the program. First, I'll ask the number of productions. So I have 5 productions. LHS will be S, then AB, again A. Let's put A, B, then again A, B. After this, let's go to B, 0, B1, again B, and 0, 1. Now it's printing the first follow all the productions sets. It has formed a table, it has formed. Now I'll put the string to check. So that will be AABB 0011. Let's see if it is accepted. It has to. Yes, it is accepted. Uh, so this verifies that the execution is done properly. Thank you.